Hi everyone, Adin this side, and let's start with numerical analysis. And this is a PG based subject. So let's start with module 1, and the first method in this is bisection method. Problem is perform 5 iterations of bisection method to find the smallest positive root. The equation for this is f of x is equal to x cube minus 5x plus 1 equal to 0. Given the equation f of x cube minus 5x plus 1 equal to 0, now let us substitute 0 in the given equation. Let us make a box first, x and f of x. First we are substituting 0. We will get, when we substitute 0 in the equation x cube minus 5x, here it is 0, here it is 0, and we get 1. Now we will substitute 1 in the given equation. You get 1 cube minus 5 of 1 plus 1 equal to 0. So 1 minus 5 plus 1 equal to 0. So minus 5, and when we get plus 2, 0 minus into plus minus, that is minus 3 equal to 0. So when we substituted 1, we got minus 3. Now we have the positive root and we have the negative root. So the root lies between 0 and 1. Let us write the statements first. Let a is equal to 0, b is equal to 1. So we got f of a is greater than 0 and f of b is less than 0. Therefore, the root lies between 0 and 1. Now let x1 is equal to a plus b by 2. So the a value is 0 and b value is 1. Don't mistake it by taking 1 and minus 3. 0 plus 1 by 2, which is 1 by 2, that is 0.5. Now we substitute the 0.5 value, that is x1 value, in that equation, which is x cube minus 5x plus 1 equal to 0. So we substitute 0.5 the whole cube minus 5 of 0.5 plus 1 equal to 0. Solve this on a calculator, and here I am directly writing the answer, which is minus 1.375, that is minus 1.375, that is less than 0. So we have got a root that is less than 0. So now we get f of x1 is less than 0, therefore f of x1 is less than 0. Statements are very important when you do the sum. Therefore, we have now f of a that was greater than 0. Now we have got f of x1, which is less than 0. So the root lies between a and x1. So we substitute the value of 0 plus 0.5 by 2, that is x is equal to x2. Now we are finding x2 is equal to 0 plus 0.5, which is equal to 0.25. Now we substitute this value in the equation again. 0.25 the whole cube, that is f of x2 equal to minus 5 of 0.25 the whole cube plus 1. Solving this on a calculator, make sure you do this cube into 3, then multiply this, then multiply this 5 into this and plus 1 on a calculator, and then you get the answer as minus 0.234, which is again less than 0. Now we get again next f of a is greater than 0 and f of x2 is less than 0. So the root lies between a and x2, and we take the value of x2. The root lies between a and x2. So x3 is equal to 0 plus 0.25 by 2, which is 0.125. Now we substitute the value in the equation again, that is f of x3 equal to 0.125 the whole cube minus 5 of 0.125 plus 1. So you get 0.3767 greater than 0. Now we have got a positive value. Therefore, f of x2 is less than 0 and f of x3 is greater than 0. So we have to take the previous root value, which is positive and negative. So the root lies between x2 and x3. So we take the value of x2. x2 value we had got 0.25 plus, and x3 value 0.125 by 2, which is equal to 0.187. Therefore, x4 value is equal to 0.187, which is greater than 0. Now, f of x4, we again substitute 0.187 the whole cube minus 5 of 0.187 plus 1. So we get the value 0.0715 greater than 0, a positive value. Then therefore the root lies f of x2 is less than 0, but f of x4 changes now. From x3, f of x4 is greater than 0. So the root lies between x2 and x4. So we take the value of x2. x2 is 0.25, that is x5 is equal to 0.25 plus 0.187 by 2, which is equal to 0.2185. So the x5 value 0.2185 we substitute in the equation, the whole cube minus 5 of 0.2185 plus 1. So we get the value is equal to minus 0.0796 less than 0. So the previous value we had got x4, f of x4 is greater than 0. Here we have got f of x5 is less than 0. Since we needed only 5 iterations, so the root lies between x4 and x5. So we take the values x4 and x5. The value is 0.187 plus 0.218 divided by 2. So the value we get is 0.2025. So the approximate value is 0.2025. Sorry, my marker is actually not working a little bit, but I hope it is clear. The method is clear.